You probably jumped up in the air before. Maybe to jump rope. Or playing a sport. Or perhaps just for the heck of jumping. Why didn't you float away into space? Why'd you fall back down to Earth? The answer is simple, my friend. Gravity. No, not the gravity you put on your mashed potatoes. I'm talking about the force of nature and physics that's befuddled scientists, philosophers, and man in general for centuries.
One of the earliest recorded theories of gravity was made by Aristotle. The teacher of Alexander the Great had hypothesized that all heavy bodies such as earth and water will move down towards their natural place, while lighter bodies such as air and fire will rise towards their natural place. Aristotle's belief was that the earth, which was the center of the universe, was surrounded by a ring of air, and above that a ring of fire. Water and earth would remain on the ground, while the other two elements would rise. Long before Newton, a theory arose in the Middle Ages from an Indian astronomer named Brahmagupta, stating that gravity was the force of attraction between all matter in the universe. This couldn't, however, be backed up until Newton had developed calculus. Now, although Newton wasn't credited with calculus, which is probably a good thing because no college student would ever like him, Newton was able to develop calculus to back up this theory. With the developing of calculus, Newton was also to develop the 3 laws of physics we still use today.
Why? I developed calculus, but this question, it just befuddles me. Why? Newton's first law of physics states that an object at rest will remain at rest unless acted upon by an unbalanced force. An object in motion continues in motion with the same speed and direction unless acted upon by an outside force. This is also known as inertia, as will be demonstrated with my friend here. As you can see, he is stationary. He's not moving. He is the object at rest. I'm going to swoop in and give him a bit of an unbalanced force, if you catch my drift. Alright. Stand by. As you can see, I ran into an unbalanced force while I was moving. Henceforth, I stopped. Newton's second law states that acceleration is produced when a force acts on a mass. The greater the mass of the object being accelerated, the greater the amount of force needed to move the object. As will be demonstrated with this soccer ball. This soccer ball, as you can see, does not have much mass, so it's not going to take a whole lot for me to put into that soccer net there. Now, this shed has a greater mass, so if I want to move this, I'm going to have to kick it a lot harder. Oh! Bad idea, bad idea, bad idea, bad idea, bad idea.
Newton's third law isn't nearly as painful to explain. His third law is, for every action, there is an equal and opposite reaction. In this example, the action is the air rushing downward out of the balloon. The reaction, in turn, is the balloon being forced upward. See, that was painless.
Ooga booga booga.